Hey, mathematicians. Hello. How are you doing? It's good to see you today. We're going to be talking about rhombi and squares. Rhombi is the plural of rhombus. All right, here we go. We're talking about rhombi and squares. First of all, let's talk about the diagonals of a rhombus. All right, the diagonals of a rhombus are perpendicular. They also bisect each other, okay? So in a parallelogram, the diagonals are perpendicular and they bisect opposite angles. My apologies. They bisect opposite angles, okay? In a rhombus, diagonals are perpendicular and they bisect the opposite pair of angles. Make sure you get those on your note cards. All right, so when we're taking a look at this picture, the diagonals of this rhombus intersect at V. Okay, if WZX is 39.5, so that's this angle right here, we want to find ZYX. So we want to find this measurement right here. So WZX right here is 39.5. We want to find ZYX. So what do we know? We know that in a quadrilateral, there are 360 degrees. We know that in a rhombus, the diagonals bisect opposite angles. We also know that opposite angles are congruent. So we can use all of that information to solve for the measurement of ZYX. If WZX is 39.5, so is XZY. And actually, so is WXZ, as is YXZ. Okay, so now I have four angles that are 39.5. So let me figure out 39.5 times 4. So I have 150 degrees. So I'm going to take 360 minus 158 degrees, and I'm going to be left with 202 degrees. That is the sum of ZWX and XYZ. And I know that those two are congruent. So I'm now going to divide that by 2. And so 101 degrees is what the measurement of angle ZYX is. Let's take a look at this one. The diagonals of a rhombus intersect at V. And we know that WX is 8x minus 5, and WZ is 6x plus 3, okay? Well, in a rhombus, all of the sides are congruent. And so what we can do is set this up as an equation that 8x minus 5 is equal to 6x plus 3. So 2x equals 8, so x equals 4. In a rhombus, the sides are all the same. Okay, so take a look at this. I want you to see this idea of parallelograms, and I like this Venn diagram look of it. You know, you've got your rectangles that are parallelograms with right angles. You have your rhombi, which are parallelograms with all sides congruent. And then you have your squares that are parallelograms that are also rectangles that are also rhombi. But it gives you a good visual of how they all relate. Okay, so how are all of those working? Just a good visual, I think, sometimes to see. All right, so conditions for rhombi and squares. So some things that we know. The diagonals, I'm going to switch to a different color. Here we go. The diagonals of a parallelogram are perpendicular, or I'm sorry, in a rhombus are perpendicular. If one diagonal of a parallelogram bisects the pair of an opposite angles, then the parallelogram is a rhombus. So as long as we have it bisecting a pair of opposite angles, then it's a rhombus. If one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. Okay, so it builds on that all sides congruent. And then I like this last one. If a quadrilateral is both a rectangle and a rhombus, then we call it a square. Right? So good information. Some of this you've heard before, but again, it's good to bring it back. It's always good to just kind of spiral it back a little bit. All right, so determining whether it is a rhombus, rectangle, or square. Okay, so kiddos, if you've been tuning out kind of this, blah, 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 I need you to hear this, okay? When you are telling me what kind of a figure a quadrilateral is, you have to be super specific, okay? Super specific, because some of these figures have similar qualities. So let's take a look. A is -2, -1. And then we have B is -1, 3, and C is 3, 2, and D is 2, -2. Okay, so this is our figure. And we want to know, hey, is this a parallelogram? Is this even a square? Is this a quadrilateral? You know, what is this? What is this? So first of all, we need to see if it's a parallelogram. So we need to figure out whether or not what the side measurements are. Okay, so I'm gonna have to use this distance formula. Bless you. We're gonna use this distance formula. So the distance of, and so hang on, this is gonna take us a little while. The distance of AB is going to be -1 minus -2 squared plus 3 minus -1 squared. So AB is going to be the square root of 1 squared plus 4 squared, which is 17. Okay. BC, it's going to be the square root of BC. So it's going to be -1 minus 3 squared plus 3 minus 2 squared gives me the square root of 4 squared plus 1 squared, which is the square root of 17. Okay, let's look at the next one. Look at the next one. CD, we've got the square root of 3 minus 2 squared plus the quantity 2 minus -2 squared, which is the square root of 1 squared plus 4 squared, which is, look at this. So far we have 3 out of the 4 sides congruent. And then DA is equal to the square root of the quantity 2 minus -2 squared plus -2 minus -1 or minus 1 squared. Minus -1. So that's going to give us the square root of 4 squared plus 1 squared. So we know that all 4 sides are congruent. That means it's going to be either a rhombus or a square, right? Because all 4 sides are congruent. So that was my first thing to do. So now that I got that taken care of, now I need to find their slopes. Okay, so the slope of AB is going to be 3 minus -1 over -1 minus -2, which is going to be 4 over 1, which is 4. So the slope of AB is 4. Now, theoretically, the slope of CD should be the exact same thing. So let's find CD next. AB, CD. Here we go. -2 minus 2 over 2 minus 3 is -4 over -1, which is 4. Okay, so we know those 2 sides are congruent, so are parallel and congruent. So I'm just going to draw the parallel symbol in there. And then let's go ahead and do the other 2. So BC is going to be 3 minus 2 over -1 minus 3, which is 1 over -4, which is equal to -1/4. Hey, that's perpendicular. Tells me it's going to be a right angle. All right, and then let's do the next one, DA. And that is going to be -2 minus -1 over 2 minus -2, which is going to give me -1/4. So what we have is that opposite sides are parallel, we have that opposite sides are congruent, and we have that all sides are congruent and right angles. So most specifically, this is a square because of all of that. Okay, and we would list what it has. It has all sides congruent. It has opposite sides parallel. And it's going to have, let's see here, what else? Oh, right angles. Right angles. How can I forget that? All right. So your assignment is listed here. Have fun. Take your time on these problems. I know I went fast for the case of the video, but take your time on them. All right. Have a great day. We'll catch you later. Bye.